Okay, so let's go ahead and get started. If we were to try to sub in x equals 1 into the equation, we would get 1 plus 1 minus 2 over 1 minus 2 plus 1, which is a 0 over 0 form. And so we obviously cannot just do it by direct substitution or by directly inputting the value. So what we're going to do is we're going to say, okay, we have x to the power of 8, x to the power of 4. That's harder to factor. So let's go ahead and just do a substitution of u is equal to x to the power of 4. And we can use the substitution rule, which states, I'm going to just write that as an aside, substitution rule. Substitute variable x with another variable u by setting u equal to g of x. Can be used to rewrite the limit. And that is the limit as x approaches a of f at g of x is equal to the limit as u approaches b of f of u. And you might remember something very similar from the first week of lab, where we did this without having had the formal definition. We did it more intuitively, but now we're at the formalities of it. And so we can do this as long as the following conditions are met. Limit x approaches a, g at x equals b. Limit u approaches b, f of u. Okay. So substitute in u equals x to the power of 4. Okay, so we'll go ahead and do that. So that, well, first let's compute what b is going to be. So limit, first compute limit as x goes to 1 of g at x, which is x to the power of 4, which is just 1 to the power of 4, which is 1. So this is b. Okay, so our function up here, limit as x goes to a of x to the power of 8 plus x to the power of 4 minus 2 over x to the power of 8 minus 2x to the power of 4 plus 1 is equal to the limit as u goes to 1. It's the same value. This a was also 1. Of, if we put this in here, that is just u squared plus u minus 2 all over u squared minus 2u plus 1. Okay, so we've done the substitution, and now we're like, okay, these are trinomials. We know how to factor those. So we're going to go ahead and factor that. So this is equal to the limit as u approaches 1 of u plus 2, u minus 1. And this is going to be u minus 1 squared. Okay, and so now that we have that, we do have common terms. So we're going to go ahead and eliminate those. So u minus 1 and the squared, that gets us the limit as u approaches 1 of u plus 2 over u minus 1. Okay. But we still see that if we were to put in u equals 1 here, we would get 3 over 0. So we still have something over 0, but what has changed is the limit as u approaches 1 of u plus 2, the numerator is equal to 3. So the numerator is no longer a 0, which means we can use our dividing by 0 limit rule, which I'll write on the next page after I freeze that. So what is that again? If f at x over g at x is greater than or equal to 0 for all x does not equal a, and the limit as x goes to a of g at x equals 0, and the limit as x goes to a of f at x does not equal 0, then the limit as x goes to a of f at x over g at x is equal to infinity. And secondly, the opposite case. So if f at x over g at x is less than or equal to 0 for all x not equal to a, and the limit as x approaches a of g at x equals 0, and the limit as x approaches a of f at x does not equal 0, then the limit as x goes to a of f at x over g at x is equal to negative infinity. Okay, so what's that saying? If we have our fraction here with two functions, and it's positive for everywhere but x at a, and the bottom it goes to 0, and the top is not 0, then this is the limit and it goes to infinity. Because basically you have a positive number at the top, and this is getting closer and closer to 0. And then the opposite case is if it is negative, then it goes to negative infinity. So we're going to go ahead and use that because we know that, let's look closely. Okay, so we know that, as we said here, that the numerator does not go to 0, it goes to 3. So we know we can use this. Except if we look closely at u minus 1, as x approaches 1, if it is coming from the negative side, so if it's always, x is approaching 1 but always less than 1, then this is going to be negative. So we can write that out. From the negative side will be 0, negative. And the limit as x approaches 1 from the positive side of u minus 1, which is the denominator, is equal to 0, positive. And So the numerator limit is equal to 3. So that's positive. Denominators so it's negative from the left and positive from the right. And I'll just write that out. So u minus 1, and this is u plus 2. And I'll just write out what we actually have. What we're actually computing right now is the limit as u goes to 1 of u plus 2 over u minus 1. So if the numerator is always positive and the denominator depends if we're coming from the left or the right, that means we're going to have to apply both of these rules, one from coming from the left and one from coming from the right. So if in our first case here, when we're coming from one from the negative, that means it's going to be the second case. So this limit we're going to rewrite as two-sided limits. So the limit as u approaches 1 from the negative of u plus 2 over u minus 1 is equal to negative infinity, or not an 8, negative infinity. And secondly, the limit as u approaches 1 from the positive of u plus 2 over u minus 1 is equal to infinity. And then we can say for our last line, therefore, the limit does not exist because the left side, so limit as u approaches 1 from the negative of u plus 2 over u minus 1, it does not equal the limit as u approaches 1 from the positive of u plus 2 over u minus 1. Oh, there you go. So it already doesn't exist because it's infinity, but infinity is a special type of limit we can still put in. But because these are not the same, it doesn't exist also because the limits from either side are not equal to each other. Are there any questions on that? Yeah. 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 So basically, when we started, we had, it was a 0 over 0, and we can't deal with that. We have to get rid of the discontinuity. So that's what we tried to do. We did the substitution rule so we could see, okay, these are just trinomials, we can factor them. And then we did that. We got rid of one of the problems at the bottom, but there was still another one. But once we got there, we saw, oh, the limit of the numerator is no longer also 0. It's no longer a 0 over 0. And when we have that case, we can use our division by 0 limit rules here. And we look at this, and it's basically, it's dependent on whether or not the whole thing's negative or positive, and f at x needs to not be, the limit needs to not be 0, which we have. And then we applied that to the two-sided limits because the overall equation was either positive or negative based on what side we're coming from. Yeah. So you're saying you divided everything by x8, x to the power of 8? Yeah. So only the first term within each would have x to the power of 8, unless you then have a division by x over 8. Typically, you're only doing that when you have limits to infinity. That is something we do a lot when we do that. You could have factored out an x to the 8, but you would have had the same case. So you're saying this, let me see, limit as x goes to 1 of what? So x to the power of 8, x to the power of 8. 1 plus 1 over x to the 4 minus 2 over x to the 8. Uh, 1 minus 2 over x to the 4 plus 1 over x to the 8. So what would you do after this step? Yeah, it still ends up being the same thing, unfortunately. So that's why, like, you could have come and factored without the substitution rule, just because it happened to be the case that the power here was twice the power here. So it's kind of just follows a pattern of a normal trinomial. There was another question? Yeah. Sorry? You're saying how did I get, okay, yeah. So what I did there was I subbed in u is equal to x to the 4. So basically you have limit as x approaches 1 of x to the 8 plus x to the 4 minus 2 over x to the 8 minus 2x to the 4 plus 1. And so if you sub in here, so let's say we have this, if you were to square both sides, u squared is equal to x to the 8. So I just subbed in u squared for these two. And then for these two, these are just x to the 4. So basically I just replaced, so that would be x to the 8 becomes u to the 2. X to the 4 just becomes u minus 2 over x to the u to the 2 minus 2u plus 1. And so you could have subbed in something else. That's just what I chose to sub in, and that got us to a trinomial I knew I could factor. When we were here, you could factor from here, but that's typically you're not factoring something with, hey guys, thank you. Does that answer your question? Okay. Yeah, you could sub it in for any value. You just got to then determine that, oh, sorry, this is u to the 1. What's the limit as x goes to a of g at x, which is just, that's u. And then that equals your new b value here. So if you have the substitution rule right here. Okay. Okay, let's go to the next question. Okay, question 2. Limit as x goes to infinity of e to the 2x over e to the 2x minus e to the x. So go ahead and now talk amongst yourselves, and you can answer that, and then we'll go over it together. Okay, so let's go ahead and get started on this one. For this one, we are going to substitute u is equal to e to the x. Okay, and so basically we want to determine what the b value is. So that is what is going to be our new limit. So we have limit, or just let's pull back up the substitution rule. So when we have a function, inside of it another function, we can replace it with u is equal to that function. And now we're changing the bounds from x goes to a to u goes to b. So we have to determine what that b value is. So we go ahead and do that. So the limit as x goes to infinity of e to the x is equal to itself infinity. If you have e to the power of something that's getting larger and larger and larger, obviously that entire thing is going to get larger and larger and larger. So when we do that substitution, we get the limit as u goes to infinity of u squared over u squared minus u. Okay, and when we have something that's going to infinity, one of the things we can do is we can divide every term by u to the highest power. And if we do that, this is equal to the limit as u goes to infinity of u squared over u squared all over u squared over u squared minus 1 over, or sorry, u over u squared, which we get that. And that equals the limit as u goes to infinity of 1 over 1 minus 1 over u. Okay, and now if we sub in u goes to infinity into this, then 1 over infinity, as small as you could get, is going to go to 0. So that is equal to 1 over 1 minus 0, which is equal to 1. So that is something you can do when you have something going to infinity. Well, you could, this is still algebraically legal for you to divide everything by the same term, but it starts to make sense when you have this case, because if you can get numbers here and get this one to still have a u in it, that can typically get you somewhere. Are there any questions with that? Yeah. Yeah. I divided every term by u squared. Yeah. Yeah. So that's one of the things you can do is you can if you get here, you eliminate the actual u's from the term and we get to an integer. So that's one of the reasons. But if you go into the if you look at, I forget what page it is on the notes or what the rule is, but there's a bunch of rules like that where it's like what to do when you're going to infinity in these different cases. And that's one of the things you can do. So I'd say check the notes for that. But yeah, that's one of the things you do when you go to infinity, because you want to get these to be integers, and then whatever's left, typically if it's over a u, it's going to go to 0. Question? Okay, guys, I cannot hear the question. I'll come there next. Yeah, go ahead. You factor out the u to the e to the x. So you're saying factor out the e to the x? Sure, let's try that. So if we factor out the e to the x, You would then still need to, well, I guess then you could divide everything by e to the x. So you get 1 over 1 minus 1 over e to the x. Yeah, so typically whenever you're using substitution rule, you don't have to use it. It just makes it easier to look at when I have u squared and u squared minus u. And I've already changed the bounds of the limit, but we could have done it that way as well. Both of them work. Yeah. Question? No? Someone had their hand up back there. No? Okay. Yeah. One to one, sorry. You're saying this line here? If you factor out e to the x? Yeah, because when you have like bases, you add. So x plus x is 2x. Yeah. Yeah. Okay, we're going to go to the next question. I will freeze this. Okay, quite similar. What is the limit as x goes to negative infinity of e to the 2x over e to the 2x minus e to the x? So really just a change of where our limit is going to. So go ahead and think about that, and then we'll take it up. Yeah.
It's just, I mean, as far as like everything went to high school, right? If you have like one thing up here and one thing down there, this is how you cancel things out.
No, because it's not a, it has to be a like term in all of them. So you can cancel these out, but if you were to cancel that out, you'd have to have a minus 1 over e to the x. Yeah, because you can't, right? Because it's like, let's say you have like a over b or minus a, right? Is that you have to common factor out from here something, and then you can cross it out. It needs to be in every single term.
Oh, okay, and then that's
right. Let's use a number example. So if we have 2 over
no, that
4
makes sense.
plus 3,
You got to factor
Yeah.
out then like
Yeah.
a over b, and then
yeah,
one.
yeah, yeah. That's why we did. Did you just erase it? Yeah, that's why these two would cross out, and that's why we common factored first. Yeah. Okay, the solution to this one is quite similar. So we're going to do the substitution once again. Let u equal e to the x. And so then we need to determine what that new limit is approaching. So that's the limit as x goes to negative infinity of e to the x is equal to 0. So the exponential function goes all the way up to infinity, going to the right, and goes down and closer to 0 to the left. So essentially what we're doing then is the limit as u goes to 0 of u squared over u squared minus u. Okay, we're once again going to get a 0 over 0 here, but if we do a division of all the terms by u squared, then we get the limit as u goes to 0 of u squared over u squared over u squared over u squared minus u over u squared. Crosses out. Limit as u goes to 0 of 1 over 1 minus 1 over u. And similar example here, 1 over u, the top, the numerator is positive. This is approaching 0. So it is going to itself go to 0. And that means this whole term is going to go to infinity. So that will essentially become equals 1 over 1 minus infinity, which is equal to 0. If you have infinity in the denominator and a positive number in the numerator, it's going to approach 0. Yeah. This? Yeah. So as we had, it's still up, no. Here. So if it's positive, or no, that's not it. Basically, if you have 1 over, oh no, that is it. Duh. Okay, so you have a positive number here, and you have the limit of the numerator is going to 1 in this case, so it's not 0. It's positive. That means the overall limit is going to be infinity. If the denominator is approaching 0. Yes, it's the divide by 0 rule. Yeah. Okay, let's go ahead and write out the last question. Just let me write it out and then I'll answer your question. So evaluate the following. The limit as x goes to infinity of root 2x minus root 2 over x all squared minus 2x. And just in case people didn't have that. Hello, how's it going? I'm just trying to find something. Okay, and the first one.
Okay, why can't we decide?
Why can't we divide on the first one? So you're saying if we were to, where's
Like,
my?
it takes someone else to divide it.
There it is, okay. So in this case, x is going to 1. So these denominators are not going to 0. So we can divide, follows the algebraic law, but this only goes to infinity when this goes to 0, when the denominators go to 0. So in this case, x is going to 1, not to 0. But because in this case, it was going to 0, that's why this went to infinity. So we could have, like, you're legally allowed to do this because this still equals the previous line, but it wouldn't be helpful in this case. Whereas if this was going to 0, you'd have then, but then you'd also have infinity on both sides, right?
So what if X is
If x is approaching infinity, we totally could have divided everything by x to the 8 there.
so it's only useful if X is infinity of 0.
Normally that's the case, yeah.
Just those.
Like it'll depend. It'll depend because like in was it approaching 1 here? Right, because this one was approaching 0, which got us to infinity. But yes, the rule is like if you come here. Like that's the one that we're looking at, is that when you're dividing by 0. So when you sub in the limit and it makes the bottom go to 0, but the top not go to 0, that's when we can use these cases here.
So we use this one for all 3 questions.
We use this for question 1. For question 2, 1 over, no, that's going to infinity, which I think there are rules in here. I'm just trying to find them. Finding, nope. There is a limits at infinity right here. So the limit so this is now, okay, we can use this rule when it's going to infinity. There's also a 0 case here. But when x goes to infinity of something to the power of p, then it's going to go to infinity, obviously. If it's going to negative infinity, it's still infinity. Then you have, that's if it's odd. Then you have a to the x equals infinity as x goes to infinity, obviously for a is greater than 1. So like there's just different rules here. So and then there's more limit rules for infinity here. If x goes to a equals infinity, then the limit of 1 over that goes to 0. Equals c.
Wait, so is this is if X is approaching infinity?
So no, so these ones are for if x is approaching infinity. That one's for if x is going to 0. And then these are for if x is going to a, and that causes it to go to infinity.
Oh.
Yeah. So there's just these different rules here. I'd say go through those, but they give you the cases of what to do when you're in these different situations. Okay. Okay. So let's go through our final example. And just overall, I did look up what the different rules were. So the first one was the divide by 0 limit rule is what it's called in the notes. And then I'd also recommend checking out where is it? The limit rules for infinity box, as that is a lot of the stuff that we just did now. I can probably throw this up here. Limit rules at infinity. Okay. Okay. So we will go through this final problem. So this, first what we're going to do is we're going to FOIL this squared term. So this is equal to the limit as x goes to infinity of square root of 2x minus the square root of 2 over x, and write that out again. Minus 2x equals the limit as x goes to infinity of root 2x times root 2x is just 2x, but we will write it out just for completion. And then it's going to be minus root 2x times root 2 over x, minus that again, root 2x times root 2 over x, and then minus, so minus times a minus is a positive, so plus root 2 over x squared, and minus 2x at the end, which is equal to the limit as x goes to infinity. Let's resolve these squares. So this will be just 2x minus, if we have these individual square roots, we can multiply them together. So I'm just going to do this in 2 steps though. So minus 2, because there's 2 of these terms, root 2x, root 2 over x. And then this is going to get rid of the square root, plus 2 over x minus 2x equals to the limit as x goes to infinity of 2x minus 2. And then we're going to combine these. So it's minus 2 root 2x times 2 is 4x over x plus 2 over x minus 2x equals the limit as x goes to infinity. These 2 x's cross each other out. So we have now minus 2, these x's inside this square root also cross each other out. So it's minus 2 times root 4 plus 2 over x is equal to the limit as x goes to infinity minus 2 times 2 plus 2 over x, and limit as x goes to infinity of minus 4 plus 2 over x. Okay, so that's all simplified. And so now there is still an x in this term, but if we were to sub that in and you have 2 over a number that's getting ever larger forever, it's going to tend towards 0. So we can just go ahead and sub that in, and I will try to pull up the limit law exactly right after this. So it's minus 4 plus 0, which is equal to minus 4 is the evaluation for that. And we look here. So that would be this limit rule right here. Can't see it. So if the limit of x goes to a, it's going to infinity in this case, equals infinity, and you divide by 1 over infinity, it's going to tend towards 0. Are there any questions on that one? No? Okay, then that's class. I hope you all have a great Thanksgiving and a long weekend. See you next week.